Problem number 9, this is a number problem. It says Dennis is 2 times as old as Eric. Now look, Dennis's age is given in terms of Eric's age. So I think what we'll do here is I'm going to let X be Eric's age now. But now we give him some information. 4 years ago, you add their ages together and you get 16. How old is each fellow now? All right, so how about if we do this? In number 9, let's get another color. Number 9, why don't we do this? Let X equal Eric's age now. And I'm doing this because Dennis's age is given in terms of Eric. So if I know Eric's age, I can get Dennis. It says Dennis is 2 times as old as Eric. So if Eric is X, Dennis must be 2X. And that's Dennis's age now. Now then we're told 4 years ago the sum of their ages is 16. Okay, now look, this is how old they are now. Eric is X. So how old was Eric 4 years ago? So if we think about, okay, let's think about 4 years ago. Eric was how old? Well, he's X now, so in 4 years ago he must have been X minus 4. And what about Dennis? Well, right now, Dennis is 2X, so 4 years ago he was his age now 2X minus 4. And then we're told that if we add those together, we get 16. You know what? Let's just do it right here. Just add these together. Just go straight down. 3X minus 8. So we get 3X minus 8 is 16. Add 8, we'll get 3X is 24. Divide by 3, we'll get X equals 8. So what was X? X is Eric's age now, and if we multiply that by 2, 2X, there's X. We get 2 times 8 is 16. So let's summarize. So how old is each now? Well, Eric right now is 8, and Dennis right now is 16. Let's go on to number 10 here. Number 10 says a table is 3 times as long as it is wide. Now I'm assuming this is going to be a rectangular table. So I'm going to draw a rectangle here. And what I know is that it's 3 times as long as it is wide. Okay, now as I read it, wide comes second. So length first, wide second. So let's let X be the width. And then what do we know about the length? Well, it's 3 times the width. The width is X, so this must be 3X. Okay? And now it says this. If it were 4 feet shorter, so if we cut this by 4, and 4 feet wider, increase this by 4, it would be a square. Okay. So we would get a square if we did this. If we took the 3X and cut it back by 4, and then we took the X and added 4. Right? Because what we're going to do is if it were 4 feet shorter, so here's the length. Cut it down by 4. So cut that by 4. And then here's the width. Make it 4 feet wider. So we'll increase that. Cut this, make this wider. So 3X minus 4, X plus 4, it would be a square. How long and how wide is the table? So this is a square. Now we do know something about squares. Each side has equal length. So this side must be the same as this side in length. So let's set these two equal. So we will get that 3X minus 4 is the same as X plus 4, right? Does that make sense? It's a square, so the length of this side is the same as the length of this side, so this must be equal to that. Let's solve this equation. 3X is on the left side, only 1 over here. Let's subtract that X. I'll subtract the X. So 3X minus X will give us 2X minus 4 equals 4. Let's add that 4. So add 4 to each side. We'll get 2X equals 8. Divide by 2. X is 4. Now, what is X? This is a word problem, so find out what X is. So just follow it all the way back. What was X? Oh, it's right up here. It's the width of the table. But we also want to know this. How long and how wide is the table? So we have the width. here's the length right here, 3x, so I can just write that right below. So 3x equals, and there's the x, I get 3 times 4, which is 12. So here's what we can do. We can summarize this as the length is 12 feet and the width is 4 feet.